Good day, everyone. In the fourth lesson of the 3D modeling course, we will explore the sheet mode. As you can guess from the name, it is designed for creating sheet bodies, that is, parts obtained by bending or stamping from sheet material. This tab becomes available when you have the 3D and Mechanica modules license. Since sheet modeling is a specific case of parametric, sketches are also indispensable here. This can be noticed if you switch to sheet modeling mode. The first command in the command panel will be Add Sketch. Let's create a sketch on the XY plane. As we see, horizontal and vertical constraints were added. But why exactly these, and not parallel or perpendicular? Constraint creation settings can be configured in the Constraint Settings menu, selecting from the list those constraints that will be used when activating the auto-constraint command. For example, let's additionally select parallel and perpendicular. Let's remove the applied constraints and apply them again. As we see, the constraints have now changed to horizontal, parallel, and perpendicular. Let's add dimensions and finish creating the sketch. Use the sheet metal command and select our sketch, after which we can set the sheet thickness. Just below, you can choose the direction to give thickness: forward, reverse, both. When we separately determine the amount of increment in each direction, and middle plane, when the body is uniformly extruded in both directions. Let's leave the forward direction and set the thickness to 5. Finish the command by pressing OK. The result of the command was the creation of a 3D body. You may ask, what is the difference from the parametric mode if it could create the same thing? The difference, as always, lies in the details, specifically in the specialized commands of the sheet mode, such as the convenient and quick addition of various bends. Let's start with the simplest: bend along edge. Click on the command, and in the window that appears, select the parameters for the future bend. First, common coefficient, which determines the position of the neutral axis relative to the sheet thickness, and can be changed from 0 to 1. Its effect is easiest to demonstrate when we get to the topic of unfolding parts into a plane. Further parameters will be easier to demonstrate if we select any edge of our plate. Click on any edge and see how preview lines appear, showing the contour of the future bend. We can choose multiple edges or remove already selected edges by clicking on them with Ctrl held down. Let's return to the settings. In the Type Bend Location field, we can set the placement of the element relative to the specified edge, whether the bend will go along the entire length of the edge, or be located in the center, say, width of 40, or asymmetrically by setting the distance separately from the left and right, or shifted to the left or to the right. In the Invert Direction field, we can accordingly change the direction of the bend relative to the sheet plane. We'll keep the All Length setting and move below to the continuation of the bend. We'll set the length to 30 and switch to the right view. In the Length Type field, we specify from which point this length will be measured: from the bend built according to our parameters of the inner or outer contour, or from the tangents, which is applicable at a bend angle greater than 90 degrees. Next, the settings for angle and radius of the bend. You can set either the internal radius or the external radius. 5 for the external is too little. Let's set 10 or 15. We see how our model changes, but let's return to the internal radius. We'll set it to 5. The bend angle can be set either as the angle bend or as the complementary angle. The next location of the Bend tab determines the location of the bend relative to the selected edge. If we enable the sketch display and look at the types of offsets. Bend line inside. As we see, the side edge starts at the level where our sketch ends. Bend line outside. The outer wall starts where our sketch ends. Also, the biprojection option when the wall's tilt angle is more than 90 degrees. And you can separately set an offset inside or offset outside in numerical equivalent. Let's set offset inside as 10 or 15. We see how our bend shifts correspondingly into our sketch. Let's keep the bend line inside. Let's return to isometry. The next lateral face tab is responsible for adding slopes on the left and right and corresponding bend slopes, as well as for expanding the side edges if necessary. For example, let's set an extension on the left, specify the amount of extension, and as we see, the model changes accordingly. We can also set an extension on the right. We don't need them yet, so let's remove them. Set the bend slope at 30 degrees. And as we see, the model also changes. It's possible to set the bend slopes separately on the left and right, and the slopes of the radial part of the transition accordingly. We don't need them yet. Let's leave them equal to 0. Let's return to isometry. The next Closing Corners tab allows you to set parameters for closing corners. It's currently empty because we have no adjacent corners. If we add a bend so that adjacent corners are formed, the tab will fill with options. For example, let's set the Allow Closed Corners Middle checkbox. After that, you can set a way of closed corner, RP corner, and overlapping closure on one side, and a tight closure. For clarity, let's select OK and edit the command. Separately, we can set the way of close bends of adjacent corners when we set the transition joint, chord, or the seam along the edge. We can also add some gap, for example, 3 mm. The last Freeing tab allows you to create slots in the sheet part to relieve the bend if it does not occupy the entire edge, but only a part of it. For example, let's remove the edge selection, set the bend location type to center, and enable Release Bend. Also, you need to set the width of the slot, say 5 mm, and the depth of the slot, say 10. We have release bends now. We can also add rounded fold release and include the width of the bend, so that the relief is achieved through the width of the bend itself. We can also set the Freeing the corner. Finish the command by pressing OK. The next command is Bend Along Line. Its feature is that the bend is created along a sketch line on the desired plane. Let's create a new sketch on the upper face of the sheet body. For a line bend, we actually need a line. Here we will add it to our sketch. Finish creating the sketch and activate the Bend Along Line command. Select the surface we want to bend and the bend line. As we can see, the part bends along the selected line. Just like in the edge bend, we can specify the bend angle, coefficient, radius type, change the fixed side, set a Freeing the corner, and the type of offset bend. Because the line was sloped, it turned out quite futuristic, so we will cancel the operation. Delete the sketch and move on to the next Fold by Sketch command. This command is needed for creating bends with walls of more complex shapes. Create a sketch of the future wall. Choose a shape different from a straight one. Finish the sketch and click on the Fold by Sketch command. Select our sketch. Select the edge along which we want to build the bend, and as seen by the preview lines, we get a bend shape corresponding to our sketch. At the top of the menu options, we can choose whether we want to make similar bends on other sides if multiple edges are selected. Or if we want to set our bend, you can set the to a certain width method build, for example, change the direction to the opposite, and set a distance end of 15. And as we see, we created a 15 mm wide bend based on the sketch. Let's edit the created bend. We will return to the method of constructing multiple edges and add another edge. All settings of this command are similar to the settings for creating standard bends. We can also set the closed corners, freeing the corner, and add, for example, a closed corners middle. Choose the tight way of closing middle corner and the seam along the edge way of closing middle bends. Press OK. And as we see, we get a tight joint of our bends, created according to the sketch. Also in this part of the lesson, we will consider creating holes in sheet parts using the hole command. This command allows cutting holes of arbitrary shapes in the part. For this, let's create a sketch of our future hole. For example, let's draw a circle, a rectangle, and a closed spline. Finish creating the sketch and move to the hole command. The command menu is straightforward. The first option, cutting, defines the working principle of the command. Whether we want to remove material inside the selected contour or, conversely, want to keep the contour, removing all other material. For example, if we select a circle and complete the command, the circle itself is cut out. If we edit the command and uncheck the cutting option, then, on the contrary, only the internal part that was cut from our part will remain. We'll undo the command with Ctrl-Z and continue editing the operation. The second checkbox sets the direction of the cut and the height of the cutting part. This is exactly the case if we want to keep not the detail, but the cut piece. Here we can specify the thickness we want to retain. Besides cylindrical holes, this command can be used to cut any closed contours. If we select, for example, an ellipse or a rectangle as the sketch, they will also be easily cut from our part, and there is no need to separately set the thickness, meaning this parameter is taken from the parameters of the sheet we created, and the cut is made through the entire thickness of the sheet. This concludes the first part of the lesson dedicated to sheet modeling. If you wish, you can practice with the commands for creating bends and holes, and move on to the next part of the lesson when you're ready.